Texas Math Mundo audience, are we in store for a treat today? In the house is a participant of the first International Mathematics Olympiad's first IMO ever in 1959, Dr. Domokos Szasz. He has also had a very distinguished career as a mathematician. He is Professor Emeritus at the Budapest University of Technology and Economics and has quite a career. It promises to be a very interesting discussion. Let me take a quick moment and ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and that you smash that like button. It helps me out with the YouTube algorithm. Let's spread this joy, let's spread this beauty to as many people as possible. Dr. Domokos Szasz, a participant in the first IMO ever, earning an honorable mention distinction, and a very accomplished career in mathematics. Right ahead. My name is Olympiad, and this is Texas Math Mundo. Texas Math Mundo audience, are we in for a treat today? In the house is Dr. Domokos Szasz. Our guest was a participant in the first IMO ever in 1959, a representative of the Hungarian team, earning an honorable mention distinction at the event. He is currently a Professor Emeritus at the Budapest University of Technology and Economics, Department of Stochastics. His educational background includes a math diploma in Budapest, also a Ph.D. in Budapest, in Lomonosov University in Moscow. He got his candidate's degree with distinction. He got a degree of the Doctor of Mathematical Sciences from the Hungarian Academy of Sciences. His professional positions include, from 1964 to 1968, he was an assistant professor, Department of Probability in Budapest. From 1971 to 1999, he was part of the Mathematical Institute of the Hungarian Academy of Sciences. In 1993 to 1996, he served as director of the institute. In 1999, he became professor, Department of Stochastics, Budapest University of Technology, and from 1999 to 2005, he was director of the Institute of Mathematics. From 2005 to 2011, he served as president, Section of Mathematics for the Hungarian Academy of Sciences, and in 2011, vice president, Hungarian Academy of Sciences. His research areas include dynamical systems, non-equilibrium statistical physics, and probability. He has earned many awards and distinctions. A few highlights include, in 1969, the Grunwald Prize, in 1984, the Research Prize of the Hungarian Academy of Sciences, in 1990, a corresponding member of the Hungarian Academy of Science, and in 1995, an ordinary member of the Hungarian Academy of Sciences. In 1995, the Cecily Prize for the Bolyai Mathematical Society for founding a school. In 2005, the Széchenyi Prize awarded by the President of Hungary, no less. In 2006, the Joseph Nader Medal from the Budapest University of Technology. And then in 2009, at the 16th International Congress, he was an invited speaker giving the laudatio for Sinai's Poincare Prize in Prague. In 2014, he became a member of the Academia Europaea. In 2014, he gave the science lecture for the Abel Prize ceremony in Oslo. He's had several visiting professorships, including twice at Dartmouth, at the Utrecht University in Frankfurt, at Princeton, and at Toronto. And this is amongst many, many awards, many, many distinctions. We are so happy. The venerable Dr. Domokos Szasz in the house. I can't thank you enough. Thank you for your presence.
Well, thank you too.
Hey, I know I mispronounced so many of those words, but I really wanted to give you due credit. You have such a stellar, such an awesome resume, and it's such a treat and a pleasure for us to have you here.
Okay. So, will you ask me or should I tell you things?
Well, let's start with by asking, how are you doing?
Well, I'm fine. Actually, I'm fine. You can calculate that I participated in the first Olympiad, so now I am 82, and I am fine.
And you're looking great.
I'm here.
And you look great.
Thank you very much. So, as you mentioned, I participated in the first mathematical Olympiad in Brașov, Romania. So it was an initiation of the Romanian Mathematical Society to start with the mathematical Olympiads, and you will see how grateful I am for their idea. But to give an idea why I am so much grateful, I have to say that I have to tell something about the history of Hungary. So I was born in 41, and in 41 there was already war in the World War II, you know? And so this war was very heavy, and actually after the war we have the Soviet system in Hungary. Hungary was occupied by the Soviets, and it was a very hard time. So the house where we lived was bombarded, and we didn't have where to live in Budapest. My father's family lived in Transylvania, in Kolozsvár, in Romania. So we escaped to Romania to the family of my father, the three of us with my mother. And fortunately, after the war, my aunt, the sister of my mother, had an apartment. Fortunately, it's not completely true. He had a son, and her husband, because of the war, did not return from the Don. So it's between Ukraine and Russia. And she invited us. So we lived, we were co-inhabitants with her for many years. Already my sister was born in Transylvania in 46. And so the life of our family for many, many years in my youth was very hard. And so I returned to the Olympics. So though the life was hard, my mother took care of my somehow development, and I received as present books the new area of the atomic world, things like. So my first idea was to become a physicist, an atomic physicist, and in '59, when I was to go to university, on the first place, I marked atomic physics, but my idea was that atomic physics is better understood in Moscow. So on the first place, I would have liked to go to this Lomonosov University in Moscow to study atomic physics. And on the second place, there was mathematics in Budapest. Now, I was a member of this Hungarian team at the first Olympiad, and I had this medal, honorable mention. Anyway, when I returned home, I learned that I was not taken to the university because of the so-called contra-revolutionary behavior of my father.
Really?
Of course, I appealed, and thanks to the Romanians for organizing this mathematical Olympiad, upon appeal, I was taken to university nevertheless, but then already Moscow was out of question, so I didn't study physics, atomic physics, but rather started to study mathematics. So this means how politics and mathematics were. Okay, so this is what I wanted to
Very interesting, fascinating story, fascinating background. Wow, it must have been very tough in those circumstances.
And I tell you another thing. You asked me in your outline about the education system when I was a student, was pupil. So we had some good teachers from before the war, because before the war, Hungary was in a sense, solid country, not without contradictions, but it was solid country. So we had some good teachers who were educated then. But during my elementary school and high school, I never learned anything in mathematics from my teachers. It happened so. But I told you that we lived together with my aunt, whose husband did not return from the war in Russia, in the Soviet Union. And she had finally a partner who was a lawyer, but he was an extremely educated person and he loved children. So with my little sister, he hid under the table because my little sister liked that. And he somehow, when I was sort in the 6th grade, probably starting then, he realized that I like playing mathematics. So when I was 12 years old, he started to play with me mathematics, combinatorics, permutations, combinations, variations, and then how to solve the second order equations, which is not hard, but for a 12-year-old, it's not absolutely trivial. Complex numbers, trigonometry. So all these I learned from him.
Wow.
At the age of 12. So this was one inspiration.
What was his name? What was his name? His name?
László Huszár.
Okay.
His name, László Huszár. So he was a lawyer, but nevertheless. And then when I got to high school, so we had 8 years elementary school and 4-year high school, middle school, secondary school. I got a copy of the journal, mathematical journal for high school students, secondary school students. And you will be interested to learn that this journal was founded in 1894
Wow.
in Hungary. And since then, it exists. And during high school, this was my main form of learning mathematics. You get 8 or 16 problems for a month, and you solve them, you send the journal the solutions, and there is a point competition, and so on and so on. And I liked it fantastically, and I was pretty successful in it. So this already determines my knowledge of mathematics and my background in mathematics. Nevertheless, I was interested in physics, as I said to you. So when I finished high school, I would have liked still to study physics, but finally I was very much happy to be able to learn to study mathematics, much the more because at the university I had some excellent mathematicians, professors. I mentioned two names, Rényi, probabilist, and Turán, number theoretician analysis. And Rényi, he was a fantastic person, a very vivid, very excellent sense of humor, a great mathematician. And actually, he studied probability theory, which he was teaching. He studied in the Soviet Union. So the Soviet school in probability theory was, I think, the leading school in the world.
Wow.
So Kolmogorov, the greatest person of this school, I consider him, together with von Neumann, who is Hungarian American, you certainly know, the two most influential mathematicians of the 20th century. This is my personal opinion, of course. Anyway, so Kolmogorov was a giant.
Wow.
So Rényi learned in the Soviet Union, and Rényi influenced me a lot. I started to work in probability theory, and so I finished university in '64. I worked in the department of probability headed by Rényi for 4 years, but then I decided that I would also go to Moscow. But Kolmogorov considered himself too old then. He was 65, so he was very young, but he considered himself old to accept a foreign graduate student. So I got to Gnedenko, a co-worker of Kolmogorov and the head of the Department of Probability at the Moscow University, Lomonosov University. And you see, I received finally a candidate's degree with distinction there, which was, he was very much supportive and so on. But during the last year of my study in Moscow, I participated in a conference where I heard a lecture of also Soviet mathematician Roland Dobrushin about mathematical statistical physics. And it was amazing. I didn't understand any word, but I understood that it was amazing thing. And I was extremely lucky because in the late 60s and in the 70s, there was a sort of new branch of statistical physics, so-called mathematical statistical physics, which was born very strongly in Moscow, but also in Paris and in the United States too. And so through this lecture by Dobrushin, I got contacted to this Moscow school, whose leaders were this Dobrushin I mentioned, and Yakov Sinai, the other person of leading great mathematician of this school. So then I changed to mathematical statistical physics, and finally, under the influence of Sinai, to dynamical systems. And this is what my recent interest is. Very briefly saying, what I have been working on is how to understand notions of statistical physics. Statistical physics, a branch of physics which was born in the 19th century, to understand pressure, what pressure is, a simple notion, or Brownian motion, or heat conduction from Newtonian physics, to derive from Newtonian physics. It's a great challenge. It's not an easy question. At present, I am working on heat conduction, so-called Fourier law of heat conduction, which was formed by Fourier, a great French mathematician, physicist, philosopher, 1810 to 20, somewhere. So at present I am working on it. Okay, so that's
awesome. What an incredible story. Awesome. I want to ask you, the 1959 Mathematical Olympiad. Do you remember your teammates? Do you remember the coach? What do you remember from the 1959 International Mathematical Olympiads?
Well, of course, I remember the coach. We didn't have a serious preparation. So we were selected. I don't know how we were selected.
Okay.
Certainly on our results on mathematical competitions for high school students. So I mentioned this journal, mathematical journal for high school students,
yes,
which was founded in the 19th century. And there are also mathematical Olympiads. So somehow we were selected, probably in the last minute, because that was a new idea. That was not a system then. Of course, I do remember my teammates. Actually, two of them became physicists, great physicists, working mainly abroad, one in the States, the other one, I think, in France. And I also had teammates with whom I studied together at the university. And so it was a very good company. And in fact, as you asked me to give this interview, I remembered a Romanian friend. I mean, then we became friends. For some time we corresponded, and I completely lost trace of him. But now I looked up whether he is somewhere, and he's a great French physicist, Nicolescu Bacharab, his name is. So
that's great. Some great memories and stuff. You know, when I look at the IMO results, Hungary is very prominently represented in the first year. So Hungary must have had an excellent mathematical tradition.
This is what I agree. So the big influence is this journal, this mathematical journal. I think it's a fantastic initiative. It was and it still exists. Now it is called Mathematics and Physics Journal for secondary school students, complemented with some informatic questions too. So it's a combined thing, but it's still, so this is one thing. Also, Hungary has pretty good, so I mentioned this Abel Prize.
Yeah.
So Hungary, 2 Hungarian mathematicians received the Abel Prize. So most of the people are from the United States, and there are 4 people from France, 2 from UK, and 2 from Hungary, and I think 2 from Israel. So somehow that's a wonder how it happens, but we really have an excellent mathematical school still, and I think the education is also, mathematical education has also good traditions. Well, when I was working at the university, I had a colleague Tamás Varga, who initiated a method, an excellent method for teaching mathematics that's called the complex education of mathematics, or the guided discovery method in mathematics.
Guided, okay.
And it's still active. Hungary is still active in this direction.
So you've won so many awards. You have so many distinctions. An incredible career. So that IMO medal, the IMO medal, the honorable mention medal, where do you keep it?
Probably I don't have to explain, because if there were no mathematical Olympiad, and I wouldn't have been accepted to university.
Yes, exactly.
Certainly my life would have been completely different. I don't know after how many years I could go to university. So it's very high.
Okay.
It's very high.
Great.
And so in your outline, you also asked me what I am doing at present.
Yes.
So at present, actually, I am doing 3 things. As I told you, mathematics, Fourier law of heat conduction. I have a fantastic family. So I have 3 kids and 6 grandchildren.
Wow.
And really very cohesive family, which is a big joy. And my father liked sports very much, and he started to not practically educate me, but to be interested in sports very early. And since then, I'm interested in sports, not on a professional by far, but I liked, and for many, many years, I was jogging for health and for pleasure and in the forest. And I used to, but now I don't do it because of my knees. And I went to, so I did skiing twice a year, and my children they also, actually my older son is now in Austria with his family skiing. But I don't do, so I stopped doing skiing at the age of 78, because I think that's the limit. But fortunately, I can still play tennis. I don't play so well, but I enjoy it very much. I play 1 hour with a coach a week and 2 hours doubles with friends And I'm very happy that I'm able to do it. So
No wonder you look so great. No wonder you look so great. Yeah.
well,
Hey,
that's luck.
so I have a question. I have many young people that watch this channel. What advice can you give for the young people? For students, what advice?
Well, you know, advice I give that you know that luck has a great influence in one's life. But one should work that luck be able to help you. And this is what I learned from my parents. I learned from this mathematical journal and my professor and so on. Then one has to work. And one has to work permanently. At the same time, one has to enjoy work and life, sports, family, and so on. So one more thing, wise advice, that one always, it's very useful to find the people from whom you can learn, and then try to learn from clever people or from nice people. So triviality, but I feel so.
Great advice. Great advice. You're not going to escape work. Work. You know what I'm saying? That's great.
Sure. Absolutely.
Great advice. Great advice. Dr. Domokos, you know, as we conclude this interview, do you have any final words or parting thoughts?
Final words. Well, so I have been enjoying the interview, and as I said, do things what you enjoy, but to be able to enjoy things, you have to get prepared to do work, and this is, I cannot tell you more, and so I can only repeat myself that I have learned a lot from other people. You know, my parents did not study, so they were not intellectuals. And for me, it was important to find some other people from whom I could learn, and it's useful.
Awesome. Awesome. Dr. Domokos Szasz, I can't tell you how much I appreciate it. I thank you so very, very much for sharing your insight, for sharing your journey with us. I'm in Texas. You know where, Houston, Texas?
Sure, absolutely. Actually, I have friends there at the university, so of course I know.
If you ever come, I hope that you call me. We'll go out and eat. You know, I'm your friend.
Excellent.
I'm a friend in Houston, so.
So if you come to Budapest, the same.
Thank you, Dr. Szász. Dr. Szász, I appreciate everything. Thank you very much, and farewell, Dr. Szász.
Farewell to you too. Bye.
Wow, what an incredible interview. What an incredible insight from Dr. Domokos Szasz, a participant in the first IMO ever, giving us an incredible insight and journey into his mathematical career. Thank you, Dr. Domokos Szasz, for that incredible wisdom, insight, and sharing your journey with us. Thank you very much. Let me take a quick moment and ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and you smash that like button. It helps me out with the YouTube algorithm. Let's spread this joy, let's spread this beauty to as many people as possible. I have plenty of wonderful things in store for this channel, and I truly appreciate your support. My name is Olympiad, and this is Texas Math Mundo. Farewell. Farewell.